Yeah, good evening, guys. So my name is Bilson Emmanuel Kwame, and in this video, I'm going to be teaching probability and statistics. And the tool that I'll be using to explain probability and statistics will be GeoGebra Classic 5. So we are going to use a lot of assistive softwares so that it can make the explanation very clear and also, yep, as clear as possible. So now let's begin. So this is GeoGebra Classic 5. If you are new to this interface, each and every bar here is having a purpose or a function, right? So here we have the points on object. They have they play a role depending on what we are doing. But in today's video, we are going to focus on probability and statistics. So one of the tools that we are going to use will be this tool. If you want to activate this tool, just move your mouse pointer to this side of the screen, right? You can see the corner side, the corner arrow. Then we activate probability. We activate the probability. You can see that when you activate the probability, this is what is going to come, right? But before I do anything using this probability, I want to explain something on my Google board. I want to explain something on my Google board or Microsoft board, right? So let me explain something on my Microsoft board. So in this video, we are going to learn probability, but well, the main thing that we use in learning the probability is what we call the normal distribution um, curve or normal distribution graph, right? So what is a normal distribution graph? When we say a normal distribution graph, in this particular video, I'm just going to call it N. I'm going to call it N normal, right? Normal distribution. So normal distribution. So normal distribution. Okay, so let me make it a D. Okay, distribution. What is a normal distribution? When we say a normal distribution, this is how it looks like. It looks like something like this, right? Then the graph is having this structure. It's having this structure. Okay, so how do I explain this structure? So whenever we say a normal distribution, let me draw the graph well. Whenever we say a normal distribution, when we say a normal distribution, it looks like something like this, right? So something like this. Then the middle of the normal distribution is the mean. So we've given it a scientific, we use a Greek name that is mu, right? This is how it looks like. So mu. So when we go to the GeoGebra Classic 5, I'm going to explain this into details using the GeoGebra Classic 5. But well, there are two things that we have to know as far as normal distribution is concerned. The first thing is to know the mu, of which this is our mean. And the second thing to know is to know our standard deviation, right? So whenever they give us a question, these two things will be given to us, the mean of the distribution and the standard deviation of the distribution. So standard deviation is how the individual values or points deviate from the mean, right? That is the standard deviation. So on a normal distribution, this is what we have. We have that the deviation, we have the first deviation, right? The first deviation. So we are going to call it 1, then as we know, theta, right? That is the first deviation. Or some people normally use gamma. but in our case, I'm going to use theta. So theta should be our deviation. So it is the normal distribution. One property of the normal distribution is symmetric. That is to say that whatever is happening at the left-hand side is also happening at the right-hand side. And the mean is the one that is causing the symmetry. That is, the left-hand side is a mirror image of the right-hand side. So what I'll be having at my left-hand side will be also 1, what? 1 multiplied by the what? The standard deviation. When I go to this side will be 2 multiplied by the standard deviation. 2 multiplied by the standard deviation. Do you get it? Then when I go to this side, it will be 3 multiplied by the standard deviation. 3 times multiplied by the standard deviation. Okay. Then when we go to this side too, it is also going to be what? 2 times multiplied by the standard deviation. 2 times multiplied by the standard deviation. Then when we go to the next line, it's going to be what? 3 times multiplied by the standard deviation. Okay? But this is one thing that we have to know, that when we are moving to the left, we are reaching negative infinity. Negative infinity. Then when we are moving to the right, we are reaching positive what? Infinity, right? So the left-hand side, the mean, right from the mean, the left-hand side is approaching negative. It is reducing, right? Let's use R for reducing. Then from the mean to the right-hand side is what? Is increasing. Do you get it? Let's use I for increasing. So let's do a recap so far on what we've done. The recap so far on what we've done is that whenever they give us, whenever a normal distribution is given, one thing that I want us to note is that the mean is in the middle. The mean is in the middle. The second thing that I want you to know that the distance from one deviation to the other deviation, the distance between, as in, let me choose a different color, as in the distance between this and this, okay, is the same distance between this and this. Then one thing that we have to note is that the area under the curve here is what we call the probability. The area under the curve is the probability, right? So let me add more information. So the standard deviation is the standard deviation of the population, right? So we know that we have two standard deviation. We have standard deviation of numbers or data, raw data, and we have that of a population. In this case, this is the standard deviation of what? A population. Do you get it? Good. So what other information do we need to understand? I'm explaining this so that when we are doing the GeoGebra, you can better appreciate what I'm doing with the software, right? So now, key things that I want you to take away from this particular presentation in here is that one, the median is, the mean is the one separating the graph or the curve into two equal parts, right? That is into symmetry, two equal parts. And the distance from this side to this side is the same distance from this side to this side. And also the distance from, also the distance from the mean to the second deviation is also the distance from also the mean to the other deviation. Do you get it? So the distance are equal. Do you get it? Now, one thing that we have to also take note is that if, let's say, we are having, let me draw another diagram here, right? If let's say, okay, let me explain it using this. If let's say that moving from, we are going to check that we want to know the probability if we are moving from uh if we are moving from, we want to know the probability if we are moving from the first deviation to the other deviation. We want to know the probability, right? And the probability is around 68%. The probability is around 68%. So in this case, we are going to use the GeoGebra to get to know it, right? When the probability is between the deviation 1. It is 1, 1 from here. So what do I mean by that? Let's come to the GeoGebra app. If we come here, you can see that the default mean that they've given us is 0, and the standard deviation that they've given us is what? 1. So look at something here. You can see that the mean is what? 0. And the distance from here to here is 0.5. The distance from here to here is 0.5. The only difference is that here is negative and here is what? Positive, right? The distance from here to what? The 1, -1 to 1 is what? Is there is the same distance from 0 to -1, and there is the same distance from 0 to 1. Do you get it? Good. So that is this, the left-hand side, as I explained on our board, the left-hand side, right? They are all approaching negative. They are all approaching negative. Do you get it? Good. Now let's continue. So when we come to the GeoGebra app, we can see when we multiply that is from -1 to 1, the probability is 0.6827. That is to say that when we multiply this by 100, we are going to get 68.27. Do you get it? We are going to get 68.27. Another thing that we can take note of. Let me come to the board. Another thing we can take note of is that, so it means that distance from 1 to -1 is going to give us what? 68.27. Okay. Another thing that we should take note of, what of the distance from, so this is the distance from -1, right? -1 to 1. -1 to 1. Okay. So -1 to 1 is giving us 68, right? 68.27. Then we want to know -2 to 2, what is it going to give us, right? So -2 to 2, what is it going to give us? So from -2 to 2, it is also going to give us a value, right? So we are going to use the GeoGebra to check. So when we go to -2 to 2, -2 to 2 means that we should come here, our input field. This is our input field. Then we type in -2. Then this side we type in 2, right? Then you key in enter. It is going to give you 95.45, right? So 0.9545. If I'm saying 95.45, that is to say I've multiplied by 100 to get it in percentage. Do you get it? Good. So what am I trying to say? It means that whenever they give us the question, right, the distance from the second one, the second one to the corresponding second item, right, the probability under the curve, right, the probability under the curve, as in the area shaded between these sides, the area that I'm shaded, the probability of getting any of the regions here is what is giving, the GeoGebra is giving as 0.95, right? When you come to the GeoGebra app, that is what the GeoGebra is giving, the area, right, under this region, right? You can see with the GeoGebra app, it has been able to show us -2 and 2. So the area under this graph is what is giving us as what? 0.9545. So when we change it to percentage, then it becomes 95.45, right? So let's write it down. 95, 95, 95 point then 45. Do you get it? 9.45. Okay. Now what if it is, we want to know the distance from -3, the corresponding -3, to the corresponding what? 3 theta. What is the percentage, right? So all these that I've written is in percentage. All this that I've written is in percentage. All this that I've written, they are all in percentage. Okay, the next thing that I want to show is if it is from -3, okay, from -3, from -3 to 3, from -3 to 3, what are we going to have? So this is from -3 to 3. Good. So from -3 to 3, when we come to our GeoGebra app, it is just by inputting -3, then to what? To 3, then enter. So we are going to get what? 99.73. That is in percentage. So we are going to get 99.73, right? Percent. Okay. So for instance, if I want to know, for instance, if I want to know the region, right? Let me come to the diagram here. If I want to know, if I want to know the region between the mu and the -1, how will I know? I want to know the region. Let me clean some space. So if I want to know, I'm cleaning. So this is going to take some time, but it is worth it because you understand, right? Okay. So if I want to know the distance between the mu and the -1 and the distance from the mean, right? The mu and the 1 here. Already we said that the mu divides the curve into two equal parts. Then we've learned that from -1, if you check here, from -1, if you check here, from -1 to 1 is what? 68.27, right? From this side to this side is 68.27. That is to say that if I want to know only the distance here from the -1 to the mu, what do you think that I'm going to do? So all that I'm going to do is that from here to here is the one giving me the 68.27. It means that if here is our x, then here too is our x. Since they are all the same, then their summation is going to give me the 68.27. That is 2x, right? Is 2x is equal to 68, 68.27. It's equal to 68.27. Good. It's equal to 68.27. So we divide this side by 2. We divide we divide this side 2 by what? You divide this side by what? 2. Do you get it? So when we do that, we are going to get our x. You can punch this on your calculator. If you punch this on your calculator, you can see that the answer that we're going to get, it will be the same answer that the GeoGebra is going to give us. Do you get it? So that you will know what is happening if the GeoGebra is giving us a particular probability. So let me explain what I just did here. So for instance, I want to know the distance from -0 point. Sorry, the mu is 0. I want to know the distance from 0 to -1, right? I want to know the distance from 0 to -1. So when I come here, here becomes what? -1, right? -1. Then when I come here, I'm going to key in what? 0. enter, you are going to know that it is the division of what we had. So if you come here, when we divide 68.27 into 2, right? If you divide this into 2, you are going to get what? 34. So let me use my calculator on my phone. So let me come here, calculator. We want to divide 68.27 divided by 2, right? So you can see that here we are getting, don't know, so it has really turned, right? But we are getting 34.13. 34.13. If we come to our GeoGebra app, what are we getting? 34.13. Do you understand what I'm doing? It means that that is the same thing that the GeoGebra is giving us. When we change this to percentage, it becomes 34.13. So what really happened? What happened was that the distance from -1 to 1, because the whole curve is a symmetry, that is to say that the distance from here to here is the same distance from here to here, right? So if I only want to know the region from -1 to the mu, I just have to divide the entire region that is from here to here by 2. And that is what is giving me the what? The 34.13 in percentage, right? So if it is 1, if it is 1, if it is 1, that is from -1 to 1. This value here is going to be multiplied by 2, right? That gives us 68.27. Do you get it? But if it is half of it, we divide it by 2. The value here is being divided by 2. So you can see that if I delete it and I do it 0, it shrinks by half, right? By deducting half, or sorry, by dividing it by 2. So it becomes 3413. Do you get it? Good. Now, what do we need to know? Now that we know that the distance from -1 to 0 is the same distance from 0 to 1, what do we need to know? Whenever they give you a question in probability of which we are going to solve one, all that you have to understand is that whenever they give you, you know that your mu is at the what? At the center, right? Then your standard deviation, which is here, gamma, which is here, is what? How much the individual values deviate from the mean, right? So 0 to 1, it is increasing by 1, 2, the next thing is 3, the next thing is 4, right? Then it is going. Then when we come here, -1, -2, -3, so it moves to negative infinity. This right side also moves to what? Positive infinity. Do we get it? Now let's come to the bar here. The bar here is used to check. I'm going to explain to you how to use it when we are doing the question, right? But in case we want to point in maybe what is the probability that a value is less than a particular value, right? This is what we use. Maybe find a probability that 20 at least, right? Let's say uh, find a probability that at most 20 people pass the examination. At most 20 people pass the examination means that 20 or less. Do you understand? So we're just going to key in 20 here, then we press on enter. So in that particular question, we get to know that the probability that at most 20 people pass the examination is going to be 1. Is that okay? Good. So then this side is for both of them, maybe between -1 and what? 1. This side is for the probability that at most 20 people passed, or do you get it? Or this student would passed. That is when the addition comes in. Then finally, the last one is showing that the probability that at least, right, at least 20 people pass, meaning X is greater or more, greater or equal to. So at least 20 people pass. At least means that It can be the value, which is 20, or it can be more. The least should be what? 20. That is what it means. So let's bring all these understanding to life by solving a question, right? So that is what we are going to do next. So I'm going to solve a question with you, then we can call it a day. If you are having any questions, so you can drop it in the comment section when this video is uploaded, right? So this is what we are going to do next. The next thing that we are going to do is, okay, the question. Let me show you the question. So this is the question. So, okay, and let me use this diagram to explain also something to you, right? So just like I said before, this is the mean, right? That is the mean, right? So the distance from the mean to the first deviation, right, is the same distance from the mean to the negative deviation. Do you get it? And since the mean divides the curve into two, they form a symmetry. That is to say that the distance from here to here is the same distance from here to here, making us aware that then their probability, right? This is the probability in percentage, are actually going to be the same, 34.134. You remember in GeoGebra, it gives us what? It gives us 68, right? Should we go back there? When you come here, then we activate this one. Sorry, we activate this one instead. You can see we have 68.27, right? Let's go to our picture. If we go to our picture, you can see 68.26. But when we round it up, we'll be getting 68.27. You get it? Good. So we are going to get 34.134. Then the next thing is that how are we getting the next one, right? To get the region between -1 and -2, this is what we are going to do. Already, you should know that the region, you have to know the region between -1 and 1, and it is simple. The region between -1 and 1 is 68.28. GeoGebra confirmed that, right? GeoGebra rounded it to four decimal places, so we are getting 68.27 instead of 28, right? From this picture that I'm showing. Do you get it? GeoGebra even gives a more accurate answer though. Do you get it? But in four decimal places, we're going to get 0.682 That is in four decimal places. Do you understand? Good. Then the distance from the -2 to 2, the distance from -2 to 2, it is going to give us 95.45 when it is in percentage. So let's go back again. Let's go back again. So that is from -2, right? Then we end at 2. You're going to get 95.45. Do you get it? So when we come to this picture, we are going to get 95.45. Then the distance from -3 to 3 is the one giving us 99.7 what? 3. You get it? So the question is, if I want to know the region from here to here and the region from here to here, what do I do? We have to just divide this into two. We get 34.13 and 34.13 since it is symmetry. If we want to get a region here and a region here, this is what we do. We have to deduct 68, this value from this. And the answer that we're going to get, we divide it into two. That is what is going to give us this side and this side. Do you get it? But when you key in this in the GeoGebra app, it is automatically going to give you the answer, but you don't know how. That is why I'm explaining that if we want to know the value for this side, the probability of this side, it is 95.45. That is the probability between the -2 to 2 minus the probability between -1 to 1. That is minus 68.268, right? The answer that you get, you divide it by 2. That is what will be the answer for this region. So when we go to the probability, when we go to the GeoGebra app, then we want to know the region between -2 and -1. -2, right? And -1. So let's confirm something here. So from negative to a negative 1, it is given us 13.591%, right? So you come to the GeoGebra app. Let's key in enter. You see that 13.59. You get when we multiply this by 100, we're going to get 13.59%. So when we come here, it is what? 13.591. So the question is, how did the person get this picture? How was it possible? To do that, it is just you subtracting the probability from -2, this region to the second region, right? Minus the probability from -1, this region to this region, right? Then you divide by 2. That is how they got this. Do you understand? Good. Then if you want to know the probability from this side to this side, right, this is what you are going to do. It will be the probability from the third region, that is 99.73, minus the probability from the second region, that is -2 theta to this 2 theta, that is 95.45. Then we divide it also by 2. We are going to get what? This region. Is it clear? Good. So the next region, in order for us to get this next region, we know that probability is up to 100, right? So it means that the rest are measuring up to what? Up to 100. So all that we have to do is 100 minus this, the 99.73%. Then we divide by 2, the answer by 2. We are going to get the remaining. Do you get it? So it is not magic. That is how we calculate it, right? You, using calculator mathematically. But the GeoGebra app has made work easier and faster. That is how we do it manually. That was what I was explaining manually. Then when we come here, the GeoGebra will make work easier. Now that we are having that conceptual understanding about what happens when we are doing it, we are going to really solve a question. Do you get it? Now let's solve a question. Anyways, these pictures, they are not mine, right? I took it from Organic Tutor. So I have to reference him, right? So that is where I got the questions from. So this is the question that I want us to solve. It says that the test scores of a physics class with 800 students are distributed normally with a mean of 75 and a standard deviation of 7. Do you get it? A mean of 75 and a standard deviation of 7. So if we are using our GeoGebra app to solve this, we have a manual way of solving it, right? The manual way of solving it is well, let's come to our board. The manual way of solving it is by, we have to redraw the diagram, but let me shift the screen, right? So if we are to draw the diagram again, then this is what we are going to do. We draw our diagram, then we know that this is how our distribution curve is going to be. But this case, we know our mu from the question. Our mu is what? Our mu is 75. Do you get it? Our mu is 75. I'm coming, let me correct it. 75. Our mu is 75. Do you get it? Then the standard deviation, how much it deviates is 7. So we are going to add 75 plus 7. What are we going to get? 75 plus 7 is going to give us what? 82, right? Good. So here becomes what? 82. Then the next one will be what? Adding 7 again to this. If we add 7 to 82, what do we get? We get what? 89. Do you see that? We get 89. This is manual. Then later I will show GeoGebra will generate this for us. If I'm doing the negative side, meaning it is reducing by 7. So 75 minus 7 is going to give us what? So 75 minus 5 gives us 70, minus 2 is going to give us what? 68. So we have 68 here, right? That is when we are doing it manually with our hands. Then we deduct 7 from here again. If we deduct 7 again, we are going to get what? 61, right? Now let's increase this by another 7. If we add 7 to this, what are we going to get? We are going to get what? 96. Do you see that? 96. Then if we deduct 7 from here again, what are we going to get? So now it's 60 minus 6. That is going to give us what? 54, right? So this is how our values are going to be when we are keying in manually. We are doing it ourselves. Do you get it? But there is one thing that we know. The distance from the distance from this side to this side. Let me use a different marker. The distance from the distance from this end to this end is the same distance from this end to this end. Then we've learned that the distance from the first deviation, right, from the mean, we are supposed to, the probability is equal to what? 68. Do you remember that? That is equal to 68 point something, right? Good. Let's say 0.27. Do you get it? Let's go 68.27. So that is exactly what we are going to get. Do you get it? So in the question, if they ask us that how many students or what is the probability of student getting the marks of or getting marks between 68, right? Getting marks between 68. So let me use uh getting marks between 68. Do you get it? And 82. Then we know that the probability is when we write it as a decimal. So the probability becomes 0.6827. Do you get it? That is the probability of students who had between 68 and what? 84. Is it clear? That is when we are doing it what? Manually by ourselves. Now let's go to the GeoGebra app. If we go to the GeoGebra app, let's refer to our question again. If we come to our question, this is our question. So we know that the mean is 75 and the deviation is what? 7. So we come to our GeoGebra app. We type in the mean is 75, right? Then the standard deviation is 7. Do you get it? Then we key in enter, right? If we key in enter, so we have values here. Let me see whether there are values here that are in showing, right? But I'm coming. This here. Okay, so you can see that those who had 68 to 82, you get it? I did the calculation in here without knowing what even the GeoGebra app is going to give me, right? So you remember that when I come to my board, I wrote this. It is going to give us 68.27. And I did this without even knowing because I know theoretically or content knowledge that the distance from this side to this side and the distance from this side to this side is what? 68.27. And I also know that how much it deviates from the second point, how much it deviates from the second point to the second point here, right? How much it deviates from the second point, which is 61, to this other second point, which is 89. What do you think it is going to be? It is just going to be what? A 95, right? So let me show you this picture, right? So when we come here, it is just going to be what? 95.45. That is from the negative 2 to 2. That is the next one. 2 steps from the mean. 1, 2. The distance between 2 steps from the mean. Another 1, 2. So that is the distance between negative 2 theta and 2 theta. That is going to be what? 95.45. Do you get it? So in explanation, if I come to my diagram, right? If I come to my board, you can see that the distance between 61, they are 2 steps away from the mean, right? 2 steps. So the distance between them is what we call, you're going to get 95 point, let's come to our picture, 95 point what? 95.45, right? If we do this, we want to know the distance, right? I want to know the distance between two, this is 75, 2 steps from the 75, right? Let me see from my board. for my diagram itself on the board, two steps is going to be 75, right? That is 89, 61 to 89. You get it? So we come to GeoGebra, 61. So 61 to 89. So 89. You can see that it's going to give me 95.45. Do you get it? Right. So the answer that we are going to get is no difference from the 95.45. Do you understand? That is the distance from any. So this board that we are seeing here is more like a standard that regardless of the values here, always the distance from the mean, two steps away left, then two steps away right, the distance will always be 95.45. That is the area under -2, the standard deviation, and 2, the standard deviation. I hope it is clear. Good. So now let's continue to solve our question, right? Then we will end this video. So the question is saying that A, what percentage of the class has a test score between 68 and 82? What percentage? So they want to know the percentage, right? So we come to our GeoGebra app. If we come to our GeoGebra app, we want to know that what percentage is between what? Is between, let's go to the mark again. We want to know that what percentage is between 68 and 82. So come to our GeoGebra app, 68 and what? And 82. And 82. So the percentage is what? 68.27. 68.27. That is when we multiply this probability, right, by 100. We're going to get 68.27. That is what is going to be the answer. Do you get it? Good. Now, let's go back to the second one. The second one is saying that approximately how many students have a test score between 61 and 89? How many students? So this, they are not talking about percentage. They are talking about students. Do you get it? So first of all, they've given us the total number of students in the class. So when we get the percentage, then that percentage of the total number is what is going to give us the number of students between 61 who had marks or scores between 61 and 89. So this is what I mean. We come to our GeoGebra app, then what they are demanding from us is 61 and 89, right? 61 and 89. So we key in here 61 and what? And 89 and 89. When we key in here, we are going to get 95 points, what, 45. That is when we multiply here by 100. We're going to get what? 95.45. So all that we are going to do is that we come here. The total number of students in the class is 800, right? Is 800. Then we've gotten to know that from 61, as the question demanded, let's go to our GeoGebra app. From 61 to 89, from 61 up to 89, right? We got to know that the percentage of students that got this score from 61 to 89, the percentage is 95.27. The percentage is 95.27, right? If I'm right, let me check it again. The percentage, sorry, 0.45. So let me erase. So 0.45. Okay. So 0.45, 0.4, 0.45, 0.45. Okay. So that is 95.45. So that is percent. That is from the GeoGebra app, right? Then from my explanation so far, you can see that it is 95.45. That is to say that 95.45% of individuals of the total population had marks between 61 and 89. So to know the number, it is just 95. You key this on your calculator. Okay. It is just 95, right? 95.4.45 out of 100. Out of 100. Then we multiply it by 800, right? Then the answer that you're going to get, you have to approximate it to the nearest whole number. Since we don't have a decimal, human beings can't be counted as a decimal. So we approximate our value to the nearest whole number. That becomes the number of students that had the marks between 61 and 89, right? Then the question then says that what is the probability that a student chosen as random has a test between what? 54 and 75, right? So all that we have to do is we come to our GeoGebra app. The question is demanding us to do to 54 to 75, right? What is the probability? 75. When we key in this, the probability is 0.4987. That is the probability of somebody getting a mark between 54 and 75. Then let's go to our question again. It says that approximately how many students have a test score greater than or equal to 96? Greater than or equal to 96 means that greater than what? Or equal to 96. Literally, that is what it means. So all that we have to do is that we have to look for the greater than sign. This is the greater than, right? When we are reading it, we read it backwards, even though this sign is less than. But since the x is positioned this side, we read it as x is greater than or equal to. But the question says that it should be greater than or equal to what? 96. Do you get it? So the probability of students who had uh, marks greater or equal to 96 is 0.013. If we change this to percentage, that is multiplying it by 100, we're going to get what? We're going to get 0.13. You understand? We're going to get 13. But it says that approximately how many students? The question demands number. Do you get it? If the question demands number, we know the probability from the GeoGebra app, right? We can do the computation ourselves. The question demands number. So the question is saying that how many students had marks greater than what? 96. Do you get it? Good. So the questions demand number. So we know that from the GeoGebra app, we are having 0.13%. That is the probability or the percentage, right? So out of 100, out of 100, then we multiply this by the total number of what? Individuals. We multiply this by the total number of individuals. If we multiply this by the total number of students, then we approximate our answer. That is what we are going to get. Did you understand? Good. That's what we are going to get. So this brings us to the end of today's class. I hope you've learned, right? Sorry if my board was messing up. Okay, I'm going to get a proper writing pad so that in my next video, I can make the class interactive and very nice, right? So what else do you have to know? So that is what I took you through, right? Then maybe let's explore. Uh, when we come here, you can get the statistics, right? The z-test of immune, right? So when you come here, you just have to type in your mean, right? 75. Mean from the question 75. Then, sorry, this is standard deviation, right? Standard deviation was 7. Then number of students was what? N was number, right? 500. This is that, okay, when we come here, we can fill the mean, okay? This is the mean. The mean is what? 70, 75, right? So enter. Good. So it will fill this table for us. Do you get it? It will fill this table for us. So z values, p values, then we'll come to distribution, we'll come to this place again. Then when we come to view, we can key in algebra view, right? Algebra, this displaces the algebra view if you want to do anything alongside the algebra, right? And so I hope you did enjoy the lesson. Have a good evening or day wherever you are.